Good day, everyone. This is Hamak Yingli, and I'm going to be your tour guide for Quantum Odyssey. I have a special announcement for you in honor of Microsoft's 50th birthday. Instead of posting every video weekly, now I'm aiming to post one video daily, although it's going to be shorter in length, to align with Microsoft's 50-day AI Skills Fest. Also, this video is also meant to be a competitor to 3 Blue 1 Brown's future quantum computing series, as he has announced that he will create videos specific to quantum computing in the near future. He has already announced that he will post videos relating to Grover's algorithm and the entanglement superposition principle. It's going to be dinky die to see who's gonna get the more views this time. I believe it's gonna be 3 Blue 1 Brown, because the original series will focus specifically on the puzzle game Quantum Odyssey. The mathematics behind Quantum Odyssey will be secondary to the actual game. As announced in my first video, Quantum Odyssey is actually a puzzle game, ultimately a puzzle game, which you have to guide disks that roll from the top to the bottom. These disks are called sigils, and these sigils have a radius and an area. When you hover a sigil, you will see this radius of the sigil, and your goal is you have to apply gates to manipulate the circuit, which has a thickness and a color as well. And sigils can change colors or split, merge based on the structure of the gate. And also it's also quite tricky because you cannot just simply select any two circuit lines and then make a connection to this, an X or an H. You have to do them like a certain set of them all at once, much like performing a move on a Rubik's Cube or Rubik's Clock. My goal is I want you to have a hands-on learning experience and the theory behind Quantum Odyssey and how this connects to quantum computing and quantum mechanics. It is analogous to how learning Rubik's Cube deeply involves studying about abstract groups and symmetries. So here is the main structure, the basic structure of a Quantum Odyssey puzzle. So Quantum Odyssey puzzle, the first term is called a sigil. Sigil. So sigil is ultimately a disk that is on one of the lanes called circuits. The number of circuits is always a multiple of a power of 2. A power of 2. And the exponent represents the number of qubits. The gate is an action which manipulates the structure of the circuitry. Like you can add an X gate over there, an X gate, you could draw an H gate. So let's do an H gate. Over there, let's see this. An H gate. Over there, and then a controlled X as well. So that only activates if the first qubit is, 0th qubit is on the 1 state. So over there. The H gate, however, because it's not a controlled gate, you have to apply it to all applicable pairs. So applying H gate in respect to the first qubit, or I could just say the zeroth qubit, because all qubits can be mapped like place values over there. And then apply a controlled X gate with the zeroth qubit as the control. Over there. The sigil would then be split into two half-sized sigils. That means of radius 0.71 each, and with the color of blue. The sigil on the right, which has the associated qubit state of 0, 1, slides into 1, 1, because you're applying the X gate on the first qubit, and I mean the left qubit this time. This is equivalent to creating an entangled state that starts from the state 0, 0, that is a blue qubit on the leftmost line, to the entangled qubits, entangled pair of qubits, technically, on the bottom. That means a half-sized sigil, so that means radius 0.71, on the 0, 0, 0, 0 qubit slot, plus radius 0.71 on the 1, 1 slot. We call this state a Bell state, actually. So here is a thing. Qubit is like the number of digits that can identify one of the many lanes. The circuitry is the lines which sigils drop from the top to the bottom and may split or join depending on the qubit gates. The gates are the actions which transform the circuit, and without controls, you have to apply them to all applicable pairs of circuit lanes. The puzzle is solved once the qubit, the sigils match the configuration that has been specified on the bottom. The entire puzzle structure is called the forge. Over there. So this is the H gate. H gate applied on the 0 qubit. This is a controlled gate. That's or C0 gate, which changes the 1 qubit, the first slot, that means the left one, if the 0 slot is 1 or on. So we have this C0 X1. Hadamard gate, it splits this thing into 0, 0 plus half size 0, 1. Now, over there, because the C gate, the C0 is like 1, then 0 in the first slot becomes 1 in the first slot. Over there. This is a sample gameplay of Quantum Odyssey. One thing that's important about Quantum Odyssey is the mathematics behind the game is based on quantum mechanics. Quantum mechanics and information. And of course, the algebra behind that focuses on linear algebra. Linear algebra, complex numbers, and of course, my favorite, Lie groups, especially the unitary group, which I could see some crystals coming in my mind. Compared to the Rubik's Cube, let's say over there, the Rubik's Cube, which has been released more than, which is also like 50 years ago, actually, 50 years ago. It's based on group theory. The Rubik's Cube, there's even like speed cubing, and solving blindfolded, multiple blindfolded. This thing is based on group theory and combinatorics. Both of these puzzles involve colors and matching. You want all the squares of a Rubik's Cube to match. To solve this puzzle, after scrambling for the Quantum Odyssey Forge, you want to bring sigils in the starting configuration to the finishing configuration using gates. But the trick is the gates have to follow the rules of quantum mechanics, or in other words, you have to apply them in parallel unless you use control. And even then, the only control has to be if the control bits are all on. Okay. So now I have explained to you what is Quantum Odyssey, the game. I have a few like basic questions about this. The first question is this game free? Okay, here's the answer. I can say it's a superposition between a yes and a no. The yes side is, yes, it is free, but that refers to the basic, more basic, the early version of the game. The early version of the game which is already available on the app stores, is free, is always free. However, it likely may not be subject to any further updates. The main version of the game that is being advertised and has been wishlistable for several months is the paid version. The main version of the game is paid. And I have to say it is around $20. Therefore, I have to say the answer for this is a superposition of yes and no. Yes, which is one state, which you can think of it as yes. Zero state, which you can think of as no. The second idea is, do you think I'm always going to be able to do the 50 days? Can I do all 50 days? Okay, this one, it's like I have to say it's a probabilistic chance. This one's harder. Like, it's hard to keep consistency. Like, consistency is always key. It's the most important part of maintaining high performance, not intensity, consistency. So can I do all 50 days? So I would say, unless there's something truly exceptional, then yes. Unless I faced a severe exception, then yes, I can do that all day, 50 days. And then third question is, why? What is the point of me making this video series? What is the point? Of all these? Okay. So Quarks Interactive, which is the maker of Quantum Odyssey, marketed Quantum Odyssey as an educational game for players to learn about quantum mechanics in a visual way. And one key tenet of this is no math required. No math required. But interestingly enough, you actually do see a lot of like these mathematics and numbers and stuff. You have to get familiarized with certain numbers like 0.71, 0.5, 0.35, 0.25, 0.18, 0.13, these stuff. Identify which of the numbers look unfavorable, which of them look favorable, and also understand how to combine these gates to perform an operation that you want, like swapping two sigils from one lane to the other. Already, and also, Quarks Interactive has also partnered with Microsoft. Indeed, Microsoft. Over there, this logo over there. Microsoft is one of Quark Interactive's partners. It's also partnered with QBraid as well, and various other quantum initiatives like Romanium. IBM is one of Quark Interactive's clients. And you will also see a few other universities as well. Romanium is also one of these clients. And I'm one of the 7 winners of the Quantum Challenge last year. So this is about what is the point of this? Educational game, or is it just another puzzle game? The last thing let's talk about is the scheduling and to explain a bit more about like why the 50 videos, why these 50 videos, why these 50 videos. Why the 50 videos? Okay, so since the launch of the Steam version of Quantum Odyssey, which is the main version, the main paid version of this game, already people are saying like this game is hard. Already like the first negative review of this game already criticized that this is a hard game. But that is a good thing. It's not realistic to have all like the reviews positive, especially if the game has become very popular. You will always get some detractors, but that is good. It makes you like less fragile and like say like, hey, this game reviews like good reviews. If like we didn't get like any negative reviews, like this thing doesn't really work this way. Like there's always going to be ups and downs. Much like, hey, like Nintendo has made some excellent games which received critical acclaim like Super Mario Galaxy and Super Mario Odyssey, another Odyssey game. But not every like Mario game was reviewed well. Like the Virtual Boy, that VR thing was a flop. At least they learned from it. The negative review says, I buy pretty much any logic sim or educational software of this type when I see it, but as much as like this concept, I absolutely cannot recommend. I absolutely cannot recommend. UI really needs a rework. Visually exhausting and reading heavy environment doesn't mix. Maybe like I have to say like this game indeed is a hard game. Yes, like quantum mechanics has a reputation of being hard. But one purpose is we want to help you learn quantum mechanics and related concepts. So quantum and related concepts, not just quantum and related concepts like Lie groups, starting from a puzzle. So learn concepts, maths, and computer science. So namely computer science, math, and physics concepts. From a puzzle, from a colorful puzzle game. Much like Rubik's Cube. Like, if you're interested in Rubik's Cube, you will be interested in understanding group theory. If you play a lot of Pac-Man, you might understand AIs and how each ghost has differing behaviors on how to chase Pac-Man. Well, Pac-Man eats the dots on the maze. Why, why the 50 days? Why the 50 days? The second one is consistency. Consistency goes beyond, goes above intensity. So I do not want you to cram. So consistency is like the opposite of cramming. It also allows you to make better connections and meaningful connections between what you have done in Quantum Odyssey and what you have encountered in real life, from solving mathematical puzzles to everyday life. Or like finding anything that's related to computer science in everyday life, like your wake up routine, morning routine to a topological sort. Why the 50 days? Third is to align with another 50 themed challenge. Namely, it is Microsoft's 50th birthday, and it is also the Rubik's Cube's 50th birthday as well. So everything looks squared. And finally, a sense of community and the importance of quantum in the future. Importance of quantum in the future. Importance of quantum in the future. Already like NVIDIA's GTC, this is the first GTC to feature a dedicated quantum section. IonQ has been featured. The Canadian D-Wave has been featured. Query has been featured. And many of these big tech companies are investing on quantum, which have made news headlines like Microsoft's Majorana with its topological computing, which topological quantum did receive some controversy. Google's Willow, unfortunately, did stop. It's a failure. Right now, ideas of parallel universe, but unfortunately, it's like, yeah, we need to work more on this. We cannot accept the state of the Willow chip state. But fortunately, like in these many inventions, one day we will realize that we can bring quantum computing back to scale, and you can learn parallel computing, parallel operations using and playing the game of Quantum Odyssey, even without mathematical knowledge. At least, Quantum Odyssey, just like the Rubik's Cube itself, is a game which mathematics, well, and especially higher level mathematics like group theory that's taught only in university classes will definitely help you get forward. So why the 50 days? But now, just one more thing. How the 50 days? How the 50 days? This is another thing I want to discuss. How can I structure the 50 days? Okay. So this one is probably likely an exception. But however, I aim to post a short video, like that's going to be like 15 minutes in length at midnight of at the midnight of UTC. So convert your clock to your local time afterwards. Most of the topics will be about, most of them will be about circuits and puzzles. Some of them, which is more likely to be hosted on a weekend, will be about mathematical theory. And side notes. What about the color scheme? For this, like Khan Academy, we use a blackboard to write the stuff with various colors. However, in computer programming languages, tokens are colored by their role. Like, is it a variable? Is it a class name? Is it a string? Colored, or is it a comment? So normally, white is for text, is mostly used for text. Blue is mostly used for equations, especially the constant part or the real part. Well, from math world, equation, like these two. The colors of the wires are blue, the circuits, blue for those which do not change the sign or phase, green for those which change by pi halved or 90 degrees around the Argand plane. That means 1 to I to neg 1. Red for those which flip the sign or rotate the position on the complex plane by 180 degrees around the origin. And golden. Golden is just the conjugate of green, and it's the other square root of -1. You will also see like these compound colors, which to your naked eye looks like two colors are being added together. For example, in the T-gate, the right-hand side, the right circuit, which is identified with the 1 qubit, 1, is a mixture of blue and green. So let's write down the complex plane. Over there. So cyan is short for the yin yang of blue and green. Interestingly enough, it's hard for me to like mix blue and yellow to make the color other than white, because these are two complementary colors. We will attempt to visualize this as gray, but it is awkward, but it's blue and yellow. We have orange, which is red and yellow. So between them is orange. It's called the yin-yang states. And there's this Christmas light thing. The Christmas light over there It's probably the one that I have to say is like the hardest to assign. Maybe I will try light yellow. Maybe. I think it's best to like try to write it as purple, just to give it like probably like a vaguely Christmassy feeling of it. So these are the circuit colors which we will use. Comments are either gray, comments or doc strings. And of course, exceptions are also going to be in red. So exceptions, which we can also try dark red as well. And then we can like probably like find like something called links for purple as well. Because when you click on the link, a hyperlink turns purple. This is a plan for the 50-day challenge. And how do you even play this game? How do you progress? Well, that's going to be the topic for tomorrow. See ya. And cheers. So cheers, mate. It's going to be the end of the day. I'm going to start my 50 days and stay tuned.